Hello everyone. I hope you are doing well and safe in this health crisis. My name is Muhtasim Shar'i. I'm a third year PhD student in building energy efficiency and advanced building materials for sustainable construction. Indeed, I'm preparing my PhD thesis in co-direction between Mohammed I University in Morocco and University Paris Est in France as well. So in this talk, I will discuss the effect of current marketed building materials in Moroccan market on the energy performance of residential buildings. So this presentation will be as follows. I'll start first by a brief introduction, and second I'll talk about the adopted methodology for the research work, and then we examine together the final results, and finally the conclusion with some discussions. As you know actually, the building sector is one of the most important worldwide energy consumers, and become one of the major preoccupations of governments. For instance, in Morocco, the building sector, including residential and trade, is responsible for over than 50% of the final energy demand and 25% of carbon dioxide emissions. More specifically, the residential one that contributes to 33% of the energy consumption. Indeed, the building sector is the largest energy saving field that we can focus on to reduce the heavy energy dependence of Morocco towards the external energy supply. To cope with these, we see two main solutions. Firstly, is the net zero energy building approach, which is based on in situ production. The aim is to produce the energy needed locally by the building for the building itself to achieve the equation consumption equal to production, which is the trend and challenge for researchers today. The second one is about the policies and strategies adopted by each country. For example, Morocco deployed a promising policy for enhancing the energy efficiency of buildings, represented by the Building Thermoregulation Standard. The main objective is to reduce the energy consumption by 15% by the end of 2030. Moreover, the Moroccan Agency of Energy Efficiency has developed a building software known as Binayat. In fact, it has been developed in 2014 for helping building constructors to choose the good composition of building materials to build compliant envelopes. In this present work, we focus on these building materials and answer the question to what extent they are efficient and to what extent they are participating in designing high performance and passive buildings. To this end, two studies were performed. The experimental study, which consists of the characterization of the thermophysical properties of a set of building materials commonly used in construction, as shown in Figure 1. The thermal transport properties of each sample are identified using the hot disk method given in Figure 2. So as you can see in Figure 3, two identical samples are needed. The first step is to sandwich the right hot disk sensor between the two identical specimens, with some pressure applied to reduce the contact resistance. The hot disk sensor indeed represents the main part of the method, serving as both a heater element and temperature sensor. So after thermal stabilization for up to 15 minutes, the samples are heated with a direct electrical current generated by the sensor. The surface temperature variation is then monitored over the time with the same sensor. And finally, the thermal properties are calculated simultaneously based on the recorded thermal time dependent response using specific parameter identification algorithms. On the other hand, and to assess the energy performance of the studied samples at the building scale, a numerical study of the impact of these building materials on the annual energy consumption of a typical residential building located in Eastern Morocco was carried out using Energy Plus software. In this slide, the experimental results are presented. Table 1 shows the thermal conductivity, thermal diffusivity, specific heat capacity, and the apparent density of studied building materials. For hollow bricks, and due to the fact that the hot disk methods are used practically for solid samples, we firstly characterized the fired clay constituting the brick. Then, we estimated the thermal conductivity of a 12-hole brick using the electrical analogy of heat conduction as presented in Figure 1, based on the thermal circuit shown in Figure 1D. For validation purposes, the thermal conductivity of hollow bricks was also characterized using the boxes method shown in Figure 3. Unlike the hot disk method, which is based on a transient technique, the boxes method calculates the effective thermal conductivity of the total samples in steady-state regime, taking into account the air pores. As you can see, the measured and the estimated thermal conductivity values of hollow bricks are in a good agreement. According to this characterization, we will use these properties as input parameters in Energy Plus simulation program to evaluate the energy performance of several typical walls in Morocco. For these building simulations, a two-story villa type with a ground floor area of 80 meters squares was chosen. The 3D model of the building, as well as the 2D plans, are shown in Figure 1 and 2 respectively. The simulations were carried out using Energy Plus software version 9.0.1. The building is assumed to be located in Oujda, and the climatic data are listed in Table 1. For the weather file, we use data collected from the High Precision Meteorological Station installed at the Mohammed I University. The main part of this station are shown in Figure 3. In fact, we simulated the thermodynamic behavior of 4 different walls according to construction practices in Morocco: simple hollow brick, double hollow brick with air gap, double hollow brick with 3 cm insulating panel, and the last one, which represents the compliant building envelope, in which the roof is insulated with a 60 mm XPS panel, according to the Moroccan construction standard. The input parameters of these simulations are listed in Table 1. In all the cases, the building is assumed to be occupied by 4 people according to the occupancy schedule shown in Figure 1. In this slide, the annual energy consumption of studied envelopes are presented. The results show that the building with sample hollow brick wall consumes approximately 69 kWh per meter square, exceeding the maximum admissible by 30%. We can notice also that the use of air gap is a good practice for designing efficient walls. Using 10 cm of air blade can reduce the heating cooling loads by 10% compared to the sample hollow brick wall. Unlike air gap, the use of insulation boards is better for designing efficient walls with small thickness, representing an energy saving of 18% compared to the reference. Moreover, the simulation showed that the use of 60 mm thick insulation boards in walls allows the construction of compliant buildings located in cold Moroccan semi-arid climates. And finally, the average monthly temperature graph shows that the available practices for Moroccan constructions and the current building materials are only efficient for passive heating. Therefore, further studies on passive cooling techniques are greatly required for achieving low-energy buildings in Morocco. As a summary, from the present study we can draw the following conclusions. Firstly, the experimental characterization allows us to develop a small building materials database from Eastern Morocco, that we can use it in parameter design analysis, for example. Secondly, the present study showed that the thermal conductivity of Moroccan cement-based products ranges from 0.65 to 0.7. Also, insulation materials with a thickness range of 3 to 6 cm are highly recommended for compliant building envelopes, especially for compliant roofs. And finally, research and development in building materials are highly needed to develop efficient building material products in order to design high-performant, lightweight building envelopes in semi-arid climates in Morocco. Thank you for watching and goodbye.